Good morning, folks. Okay, welcome back, everybody. I hope you're doing well. Hope you had a nice weekend. So, of course, everybody has the lab exam on their mind, and I understand that. Usually, I can tell when it's an exam day because attendance is not too good sometimes on an exam day. So, we're a little light here with our group. But anyway, welcome back. I hope you're doing well. As I look at the syllabus, can you believe it? Today is November 2nd. We are in November. And even if we are to count this week's worth of lectures, you have basically 6 weeks worth of lectures left in the semester, followed by a week of final exams. I mean, the semester really is going quickly. It's accelerating. And, hopefully that helps motivate you that we're moving towards a time of rest. Okay, so hang in there and take care of yourself. So do you have any questions right now before I get started with some additional content from chapter 9? Okay, so so Rebecca is asking how many questions and how long do we have for the test? Rebecca, the exam has 35 questions, so you have 35 minutes. Okay. All right. So we'll go through chapter 9 content today and probably start chapter 10 as well in your notes. Just take some notes. Don't worry too much about it. Obviously, the big deal is at 9:30 today, you're going to want to log into ClassMarker and take your second lab exam, okay? So good luck to you folks. I know you've been studying hard. That preparation is going to pay off today, okay? All right, let's begin. Okay. I'm going to share my screen with you. All right, so you may recall from last time, we had started chapter 9 and we were talking about the various ways we could categorize joints. Basically, there's two primary ways we can talk about joints. We can talk about joints from a structural classification perspective. And when we talk about structural classification, the relevant vocabulary words that come into mind are fibrous joints, cartilaginous joints, and synovial joints. We defined those last time for you. An alternative and comparable way to define joints is a functional classification vocabulary. Functional classification vocabulary included terms like synarthrosis, amphiarthrosis, and diarthrosis. Okay. So what we're going to do today is walk through some of the figures in chapter 9 together and highlight some of the various fibrous joints of the body. Many of these things are going to be familiar to you because you do have your skeletal knowledge from lab exam 1, and that's why we do this, right? Because you're building a foundation for yourself. After we're done with that, we're going to move to rotational terms, and as I said, that's basically all I'm going to ask of you in chapter 9. So okay, here we are. Number 1, types of fibrous joints. Let's take a look at figure 9.1 here. That's where I'm at, figure 9.1 in your textbook. And we're going to list these things out for you in your notes. Okay, so the first type of fibrous joint, the one that you are probably super familiar with, is that of a suture. Okay, so just take a look at figure 9.1a. Figure 9.1a, a suture is a fibrous joint that's only found between the bones of the skull. Okay, so our example here could be any of the sutures that you became familiar with for lab exam 1. I'll just list down the coronal suture as an example. Okay, there's an interesting and funny word that comes up here. We've said previously, you are aware of the fontanelles of the infant skull, the so-called soft spots, that as the infant matures will eventually turn into real bone tissue. Those soft spots will ossify. When a suture ossifies, okay, then the suture is actually known as a synostosis. That's one of these kind of crazy vocab words here, okay? A synostosis is a suture which has completely ossified. Okay, in other words, when the infant fontanelles have finally completed the process of turning into bone. Okay, so a synostosis is a suture, okay, but it is a suture that has completely turned to bone. Okay, next type of fibrous joint are the syndesmoses. Syndesmoses, you can see there, panel C of figure 9.1. Syndesmoses, figure 9.1C, as in Charlie. A syndesmosis is a fibrous joint which is defined by a greater distance between the articulating bones than you would have with a suture. So there's a larger separation of the bones than you find in a suture. And in addition to that, there is an additional amount of dense, irregular connective tissue. This is a fibrous joint defined by a greater distance between the articulating bones than you would find in a suture, and these joints have a larger quantity of dense irregular connective tissue. Okay, let me give you the example, one of the examples in your book here. In the bottom left corner of the figure, in the bottom left corner of figure 9.1, take a look at the anterior tibiofibular ligament. The anterior tibiofibular ligament is an example of a syndesmosis. Okay, so you know from studying the bones in from studying the bones in lab exam 1, as you were looking at visible body, there are many ligaments throughout the body, and by and large, we're not asking you to learn barely any of them, really, right? Not in this course. But so you can, we did talk about the anterior cruciate ligament a little bit in lab, right? Well, here's another example of a ligament. This is a syndesmosis, the anterior tibiofibular ligament. Okay, another example of a funny, odd word I like to include with students here would be the gomphosis you see of your teeth. So look at the right side panel of picture C there, and you see the connection between the tooth and the socket of the bone, right? And the socket of the bone. So a gomphosis is a syndesmosis between the roots of the teeth and their sockets. As you remember, the socket is called an alveolus. Okay, gomphosis. This is a type of syndesmosis specific for the interaction of a tooth with its alveolus. Okay, so some of these funny words are creeping up here in our notes. And I'm bringing these up because they are legitimate vocab words for testing purposes, right? So synostosis is something I want you to pay attention to. Gomphosis is something I want you to pay attention to. A synostosis is a type of suture. A gomphosis is a type of syndesmosis. Okay. All right. Okay, folks. That would be the types of fibrous joints. Do you have any questions at this time? Okay, pretty straightforward. We just look at these things, take note of them, be sure we're focusing on them in the moment, and everything goes okay. All right, let's continue to the cartilaginous joints. Cartilaginous joints are figure 9.2. Okay. All right. So let's talk about these. Remember, when we're talking about a cartilaginous joint, we're talking about a joint where the articulating bones that are interacting with each other are held together by either hyaline cartilage or fibrocartilage. Okay. So in terms of the types of cartilaginous joints in figure 9.2, we can point out two major categories. We have the synchondrosis category. Synchondrosis is singular, synchondroses is plural. Okay. A synchondrosis is a cartilaginous joint in which the connecting material is hyaline cartilage. Okay. So examples of a synchondrosis would include the epiphyseal growth plate, right? We highlighted the epiphyseal growth plate when we talked about the anatomy of a typical long bone. And remember, we said the epiphyseal growth plate is really kind of more positioned in the metaphyseal region, right? But at any rate, an epiphyseal growth plate, as you see there on figure 9.2 in the center picture, would be an example of a synchondrosis. Okay, the epiphyseal growth plate of the femur is an example. You also see there in the left picture there, you also see the joint between the first rib and the manubrium. That joint is also an example of a synchondrosis. All right, number 2 here, the second category of cartilaginous joint would be a symphysis. Okay, not a symphony, but a symphysis. A symphysis. Okay, a symphysis is a cartilaginous joint in which the ends of the articulating bones are themselves covered with hyaline cartilage. But in between those pieces of hyaline cartilage on the articulating bones is another sheet of fibrocartilage. So take a look at the pubic symphysis, which you may recall from your study time for lab exam 1. So a symphysis is a cartilaginous joint in which the ends of the articulating bones are covered with hyaline cartilage, and there's an additional layer of fibrocartilage in between the hyaline cartilage. Okay, so an example here would be the pubic symphysis. Okay. Another example of a symphysis, which is not in figure 9.2, would be your intervertebral discs, right? All the discs, right? So the bones of the vertebra are going to have a little bit of hyaline cartilage there, but the disc itself is primarily made of fibrocartilage, right? So the intervertebral joints between the various bodies of the vertebra that are stacked on top of each other, those are going to be examples of symphyses as well. Okay, folks, any questions? All right, so for types of fibrous joints, the big categories are sutures and syndesmoses, and then there's examples of them that you can consider. Same thing for types of cartilaginous joints. The two big categories are synchondrosis and symphysis, and some examples there that you can take to heart. All right, the third type of structural classification would be the synovial joint. Okay, so let's take a look at synovial joint. All right, so there are not different subtypes of synovial joints. There's simply a consideration where we need to talk a little bit about the structure of synovial joints. Okay. And so I suppose we can use figure 9.3 at least as a starting point. We can do that. So figure 9.3 would be an example of a synovial joint. And honestly, many of the other joints that are actually highlighted in this chapter are also going to reveal that structure to you. So just as an example, figure 9.12. Figure 9.12 is the shoulder joint. That would be a beautiful example of a synovial joint. Okay. Let's talk just a little bit about some of the features of synovial joints here. Okay, so a synovial joint is a synovial joint because it has this space called the synovial cavity, okay? And that synovial cavity is itself filled up with a type of fluid which provides lubricating properties to the bones that are kind of rubbing up against each other. That lubricating fluid is called synovial fluid. Okay, so synovial joints contain a synovial cavity. Okay, so in figure 9.3, there, you can see picture A, and it says the articular cavity. Well, in this context, the articular cavity is the synovial cavity there, right? So let me ask you in the chat window, let me just ask you to make sure that you're putting an eyeball on these things. In figure 9.3, part A, what color is the articular / synovial cavity? Okay, great. All right, seeing some correct answers come right up. I appreciate you following along, folks. Thank you. You're absolutely right. It is yellow, okay? So that's what we're talking about when we're talking about the synovial cavity. Good job. So synovial joints contain a synovial cavity that is filled with a lubricating liquid called synovial fluid. All right, so there's some catchphrases here, right? Synovial cavity, synovial fluid. The The articular cavity itself is going to be surrounded by what's known as an articular capsule there. Okay, so again, figure 9.3, part A, along the right side of part A, and equivalently along the left side of part B, you see the articular capsule. The articular capsule encloses the synovial cavity. I'm going to tell you what that articular capsule is actually made of. Take note of the articular capsule, which encloses the synovial cavity. The articular capsule, if you will, is made of, okay, first it's made of an outer fibrous membrane, okay. In figure 9.3, if you're looking at part A on the right side, you'll notice you see the fibrous layer. On picture B along the left side, you see the fibrous layer. Okay, so the articular capsule is made of a fibrous layer, which is sometimes referred to as a fibrous membrane. Okay, the fibrous layer, or alternatively, the fibrous membrane, is actually a thickening. It's actually a thickening of the periosteum that covers the compact bone. So the fibrous membrane is an overly thickened periosteum. Okay, so I'll put it down that way in your notes. The fibrous membrane is an overly thickened region of the periosteum. Okay. And then in addition to that, you'll also take note of the language synovial membrane. Okay, there's a synovial membrane as part of the articular capsule. This membrane is actually made of areolar connective tissue, which has quite a bit of elastic fibers, which allows for a little bit of stretchiness within the joint. Okay. All right, folks. So this is just some basic structural characteristics of a typical synovial joint. You know, some of the anatomy we highlighted in figure 9.3, we can find in figure 9.12, right? So if you would just kind of page back to figure 9.12 there. Okay, figure 9.12. Let's take a look. Let's take a look at picture C. Picture C is in Charlie. Picture C is in Charlie of figure 9.12. And I'll just turn your attention to some of these things, right? So here we have the shoulder joint, which you're somewhat familiar with, right? The head of the humerus locks into the glenoid cavity of the scapula, right? And so on picture C, as in Charlie, on the bottom right corner, you notice the articular capsule there as well, including the synovial membrane and the fibrous membrane that we've just put into your notes, okay? So you could look at any synovial cavity. You could look at any synovial cavity and find these corresponding structures, okay? Now, let's talk a little bit about the synovial fluid. Okay, the synovial fluid is made of a substance that I know I've mentioned probably one time in this class, so I can understand if you don't recall it. But let me ask you a question in the chat window to see how good your memory really is. Here we go. The ground substance of the extracellular matrix of connective tissue contains a molecule that flesh-eating bacteria use for food. What is the name of that molecule? Do you remember the name of that molecule? Anybody recall the name of that molecule? Do you remember me mentioning it a long time ago? Okay, here's a hint. The molecules, I'm going to put this in the chat window. Starts with the letter H. Starts with the letter H. Okay, I guess this might be a bridge too far for us this morning, and that's okay. But the molecule I'm fishing for is hyaluronic acid. Hyaluronic acid. You're like, oh yeah, obviously that's what it is, right? Yeah, okay. Well, folks, that's what it is. Synovial fluid is made of hyaluronic acid that is mixed in with interstitial fluid, which is actually filtered blood plasma. Okay, so synovial fluid is made of filtered blood plasma with a lot of hyaluronic acid dissolved in the fluid. Okay, that's what it's made of. All right. And so these features together, the presence of the hyaluronic acid with the filtered blood plasma, actually provide those lubricating features we need in a joint like the shoulder. Okay. All right. Okay. Let's see here. I think what I'm going to do is I'm going to put a couple vocabulary terms down in the notes at this moment, and I'm going to ask you to do your own defining of these terms during your private study time so we can move on to the next topic. Okay, so I'll say this: be aware of the following vocab terms. Okay, so I'm not going to define them for you. I'm putting them in your notes as something I want you to define during your study time. Those terms would be menisci, labrum, bursae, and tendon sheaths. Tendon sheaths. Okay, so 4 terms here I'm going to ask you to define during your own private study time. Okay, other than those terms, folks, I am not going to be asking you additional anatomy from this chapter. It's just not going to happen, okay? Do you have any questions right now? Okay, well, let's continue, folks. So our goal for finishing this chapter up then is talking about the types of motions you're going to find at the synovial joints. Okay, so in my textbook, this starts on page 276, and I'm talking about information that is near figures 9.4 and 9.5. Figures 9.4 and 9.5. Types of movements at synovial joints. Okay, so there's 2 categories of movements at synovial joints. One of them is very minor, so we'll define it, move on. The other one we need to spend more time on. The 2 types of movement categories are gliding movements and angular movements. Okay, so we'll take the easy one first. The easy one is the gliding movements, which you see in figure 9.4. 9.4, okay. And so Okay. Gliding movements refer to side and back and forth movements where there is no significant change in the angle of the bones that are articulating. There's no significant change in the bone angle. Okay. Let me define this, then we'll do the motion together. Okay. So this is side to side and back and forth motion. There is no significant change in the angles, in the angle between the articulating bones. Arguably, the best example would be the motions that you could do with your wrist or ankle when we're talking about the, the carpal bones or the tarsal bones. Okay. Motion between the bones of the wrist and ankle. You see for yourself in figure 9.4, right? If you hold your hands out in front of you like I'm doing, right, with your two hands up like this with the palms facing towards you, and you just wiggle your wrists back and forth, left and right, that would be an example of gliding motion, okay? And so when you do that, what you can visualize is the carpal bones in your wrist are actually gliding back and forth against each other, kind of like this motion right here. Okay, so that would be an example of gliding motion that we could illustrate straightforwardly for you. That is one type of movement at a synovial joint. Okay, the next category, which we'll spend a lot more time on, and which I will highlight for you that looking at today's schedule in the syllabus, it is significant that we are now literally 2 weeks away from your second lecture exam, right? Exam 2 is going to be on Tuesday, November 16th, 2 weeks from today. And so one of the major essays in exam 2 is going to be involving the angular motion terms, which I'm about to put in your notes, and which we're going to do together as a group, okay? So you can expect that later today, I will post the normal materials to Wiley Plus that I always do, the class lecture notes from today and the lecture recording hyperlink. In addition to that, I will also be putting up the study guide for lecture exam 2. I know you're not worried about it now because in an hour you'll be taking your lab exam, and that's what's on your mind now, and that's okay. But please be aware that later today, the study guide for lecture exam 2 will be put into the lecture component of Wiley Plus. Okay. All right. So let's talk about these angular motion terms. Okay. Now, if you can see my arms straight out in front of me in the video window, right? Hopefully you can see that, right? If you think about the elbow joint, right? So this joint here, my elbow joint or your elbow joint, okay? When your arms are straight out like this, right, you're going to have your radius and ulna here in your lower arm and your humerus up here, right? And if you think about the angle between the lower arm bones and the upper arm bones, and I'm moving my hand, but the video window is not really working here, okay, as that angle would be basically 180 degrees, right? It would be a straight line. But if I flex my elbow by contracting my biceps brachii muscle, right? Now, all of a sudden, this angle in math class, in geometry class, this angle becomes less, okay? So folks, just humor me for a moment. In the chat window, what angle am I showing you right now? What angle am I showing you at my elbow? Okay. Good, good, awesome. 90-degree angle, a right angle, that's right. So that's what we're talking about here when we mean angles, okay? All right, so angular movements. Okay, angular movements refer to motion in which there is an increase or decrease in the angle between the articulating bones. Right? When the bones of our wrist are gliding, okay, there's basically sort of a rubbing back and forth, but there's no significant alteration in the angle between the bones. The bones kind of stay in place and they simply glide back and forth. That's characteristic of gliding motion. But in articulating, in the angular motion terms, you're going to have a very noticeable change in the angle of the bones that form the joint. Okay. All right, and so there's many terms we can describe here. What we're going to do is define all these terms into your notes. Then we're going to do a fun little geeky activity together that I'm hoping you'll cooperate with me at home, just to have a little bit of fun and do something a little bit different today than we normally do. Okay, so let's define these things, and and then we can have some fun with them. Okay. And as I said, most of the terms that we're going to be defining are going to be highlighted on figures 9.5, 9.6, 9.7, 9.8, 9.9. Okay, so there's several images here. So figures 9.5 to 9.9 is where we're taking these terms. All right, so flexion, that's an easy one, right? I just illustrated that for you. Here's flexion. 1, 2, 3, flexion. There's going to be a decrease in the angle between the articulating bones. A decrease in the angle between articulating bones. Okay. The opposing action, right? If I start with an elbow that's sort of a 90-degree angle at this point, if I were to relax my biceps brachii and I were to contract my triceps brachii, I would lower the palms of my hands. So here's extension. 1, 2, 3. Extension, right? Okay, so extension is an increase in the angle between articulating bones. Many other terms. We have lateral flexion. Okay, lateral flexion refers to movement of the trunk sideways from right to left at the waist. Okay, so if I'm doing that for you, okay, this is lateral flexion. Maybe you take an aerobics class, a yoga class, some kind of fitness class at the gym, and maybe you warm up by doing lateral flexion stretches, okay? So movement of the trunk sideways from left to right and vice versa at the waist. All right, we have hyperextension. Hyperextension. Okay, hyperextension is continuation of the extension motion beyond the natural anatomical position of the body. Okay, let's define it. Let's talk about it. Hyperextension, the movement, hyperextension is the continuation of extension beyond the normal anatomical position of the body. Now, okay, so imagine for a moment that I start out with my elbows here, and in the next motion, I'm going to flex. So I straighten out my arm. Now imagine for a moment if I were involved in some kind of sporting injury in football or, an aggressive sport of some kind where you actually try to invert the elbow. you try to invert the elbow. All right, go ahead with your own arm, try to push up your elbow with your other hand to a point that it feels uncomfortable. That is hyperextension. Why you can tell when people injure themselves, in sporting events and things like that, you might go to the doctor and they say, well, you've hyperextended your knee. You've hyperextended your elbow. That's what they're talking about. When you move the extension beyond the natural range of the anatomy of the joint, that's hyperextension. Okay, folks, any questions? Let's talk about abduction and adduction. Abduction and adduction can be shown in figure 9.6. Okay, figure 9.6 for those that have their textbook available. Okay, abduction and adduction are like two sides of a coin. They're like a heads and tails. It's kind of like peanut butter and jelly. They go together. So abduction is the movement of a bone away from the midline. Okay, and so I know it's hard for you, this works much better when we're in class together so we can see each other, right? I can't see you and you can't see all of me either. But if I start in anatomical position with my arms down by my side, if I take my arms and move them away from my midline, away from my trunk like this, that is the act of abduction. Okay, so moving away from the midline is abduction. And adduction is movement of a bone toward the midline. So if I start with my arms out like this, and I bring them back towards my waist, towards my midline, as I lower them, that is adduction. The analogy I use with students, and which is honestly not a perfect analogy, however, is the idea of a snow angel, right? Have you ever made a snow angel when you were a kid, or even if you're a big kid today playing outside when it snows, and you lay down in the snow, right? And you move your arms like this to make the wings of the snow angel in the snow when you're laying on the ground, right? That would be abduction and adduction, abduction and adduction. So both of these motions together are the snow angel motions. Okay. Creating a snow angel involves abduction and adduction. Okay, let's continue here. Circumduction. Okay, circumduction is shown to you on figure 9.7. Okay, I'm not going to really be able to show you that too well with my leg because, well, you can't see my leg, right? But circumduction is the movement of the distal end of a body in a circular motion. So if I were to turn to you laterally so you can see my profile, and I were to lift my arm up like this to you, and I were to rotate my fist, you notice that my fist, if you just look at my fist and not my arm, just at my fist and not my arm. If you look at the fist, you see the fist is basically moving in a circular motion. That would be circumduction, okay? The movement of the distal end, and that's why I said look at my fist, not my arm. The movement of the distal end of a body part, like your arm, in a circle. And you can see that in figure 9.7. We also have rotation. Rotation is fairly easy for us to illustrate, right? Anytime you turn your head to the left or turn your head to the right, such as you might do when you're crossing a street to be sure there's no traffic coming by, you turn your head to look, right? As you should for safety purposes. That would be an example of rotation. Okay. Rotation is when a bone revolves around its own longitudinal axis. Okay. Okay, and again, you can see that in figure 9.8. Okay. Next term, circumduction. Oh, no, excuse me. What am I doing here? We have a bunch of special terms, which will be figure 9.9. And so let's continue here. We have elevation. Elevation is a motion in which the body part is moving superiorly. So this is a superior motion. Okay, take a look at figure 9.9 there. Okay. And so an example of elevation is when your mandible is open. So when your mouth is open and when you lift it up to close it. So when you lift it up when you're chewing food to close your mouth when you're chewing food, that would be an example of elevation. So when I start here and I close the mouth, that is elevation, okay? Next, we have depression. This is sort of a comical way of thinking about this. Depression is the opposing motion of elevation. So that means it's an inferior motion. So that would be like starting with your mouth closed and opening it. And so, for me, the way in my warped brain, the way I think about it is, if a politician opens his or her mouth, I become depressed, right? This is depression. Depression is an inferior motion. If a politician opens his or her mouth, I become depressed. Okay, very good. Let's continue here. Next, we have protraction. Okay, protraction. You can see in panel C of figure 9.9, protraction is when you move a part of your body forward anteriorly in the transverse plane, right? So that would be the chicken head motion. Okay, I start here and I move forward. That is protraction. Movement of a part of the body anteriorly in the transverse plane. Okay. Well, the opposing motion of protraction is retraction. Retraction is a return from protraction. Okay, so if you have your chicken head forward and you bring it back into a natural, comfortable anatomical position, that would be retraction. So I'll do that for you. Protraction, retraction. Okay. All right. A couple more here, then we're going to get you out of your seats, folks. All right, next is dorsiflexion. Dorsiflexion is also highlighted in figure 9.9, letter G there, okay, letter G there. Dorsiflexion is when you stand on your heels, right? The bending of the foot upward at the ankle. All right, The opposing motion, or sort of inverted motion, of dorsiflexion is going to be plantar flexion. Remember, for lecture exam 1, you had to learn the parts of the anatomical position, woman, in chapter 1. Remember the dorsum and the plantar region of the foot, right? So the plantar flexion is when you bend the foot downward at the ankle and basically you stand on your toes. Okay, just a couple more here. All right, now we have pronation and supination. This came up a little bit in our conversation together in lab. Pronation and supination are similar in the idea of abduction and adduction, in the sense that these two terms go together, right? Abduction and adduction go together like peanut butter and jelly. Pronation and supination are the same way. They go together like peanut butter and jelly, okay? So pronation is a motion in which your palms turn posteriorly. Palms turn, let's see, I want to do this differently. Pronation is the motion in which your palms rotate in such a way so that when they finish their rotation, they are positioned posteriorly, okay? Okay, so normally if we were in class together, I would show you this, but it's hard to show you where we are right now. If you could imagine that my hands were completely down, comfortable in anatomical position, and so the palms are facing forward, right? Palms are facing forward in anatomical position. If I lift my arm a little bit uncomfortably to try to show you in the video camera, my palms are faced forward. If I take my palms and I rotate my thumbs towards the midline so that the palms are now facing back, palms are now finished in a posterior perspective, that motion is pronation, okay? So if I were to start an anatomical position and I were to raise my arms at my shoulder so that the palms are facing the ceiling, if I were to pronate my arms at that point, I would rotate my thumbs towards the midline and the palms would finish in a downward perspective, okay? That would also be pronation. So the opposite motion of that, which I haven't put in your notes yet, is supination. Supination is when you start with your palms posterior or down from this perspective, and I rotate my thumbs away from the midline so that my palms face up, or if I go back to anatomical position, my palms face forward, okay? All right. That is supination. Motion which the palms of the hand finish anteriorly. Okay, here we go. Pronation. Supination. Okay. All right, and then finally, one more term we're going to put into your notes is the opposition term, which you can see in panel I there of figure 9.9. Opposition is when you move the thumb to touch your fingertips, right? Move the thumb to touch your fingertips. Okay, folks. So, it's a little bit cut and dry, but these terms may come into play in a medical career if you need to position a person's body to take an x-ray, or if you do engage in any kind of physical therapy career where you're positioning a person's body to properly do exercises to heal an injury of some kind. And so we do want you to have familiarity with it. And while you can look at the pictures, it's much better to actually do them yourself. Let me see. Lauren, you say in your chat window, in a previous anatomy class I've taken, we used the analogy, your arm goes up when you get abducted by aliens and goes down when you adduct it to your body. Okay, thanks, Lauren. Yeah, absolutely, right? If that works for you, that's fine. Each one of us has to find these kind of little mental tricks that we do to get information to stay in our brain. So that's quite okay. Thanks for sharing that. All right. I'm going to encourage you as you learn these things for your exam in 2 weeks, that you make part of your study time actually getting up and moving your body to feel the motion of the term itself. In other words, I want you to experience the motion, if you would. People tend to be a little self-conscious about these sorts of things. But hey, if you're home in your bedroom, sitting in front of your own mirror, or in the bathroom in front of the mirror, who's going to know? Who's going to know? So get up and do these things as you're studying the terms, and feel how your joints are moving, feel how your muscles are contracting as you do these things. So I'm going to ask you now, in the privacy of your own home, to please stand up, get out of that chair beside your computer. Let's do some of these things together, okay? And, this is one of these things where it's fun to do as a group because we can laugh at each other. Today, we can't laugh at each other. You can laugh at me because you can see me, but we can't see each other by and large. So it's a very safe place. So please stand up and let's do some of these things together. Okay. So I'm going to give you a couple of silly little activities to do. So stand up in a comfortable place in your room, wherever you're taking the class. I would ask you to stay near a desk or a chair or a wall, so that if you lose your balance, you can stabilize yourself and not fall over, right? I don't want you to hurt yourself while you're doing this. So stand up, but make sure you're near some place that you can stabilize yourself if you lose balance. Okay, so I'm going to do a number of these with you, and I hope you will participate at home. If you get nothing else out of this, it will help wake you up this morning, okay? Because you got to be awake. You got to be awake at 9:30 to take that exam, okay? All right, so just stand comfortably in anatomical position wherever you are. For me, I'm going to turn so I have just a little bit of space near my desk, okay? And what I'm going to ask you to do, and if you need to reach out an arm on the desk to balance yourself, that's okay. What I want you to do, I'm going to give you a motion to do, and then I want you to do it, and I want you to try to hold it for a little bit while I ask you to do other things as well, okay? So let's have some fun here. So at this time, standing comfortably in anatomical position, I would like you to hyperextend your right hip. Hyperextend your right hip. Okay. Now, if you were in front of your keyboard, I'd ask you what you're doing right now, but don't worry about it. What you should be doing right now is that your right leg should be behind your body, right? Your right leg should be behind your body as you hyperextend your right hip. Now, with your right hip extended, I want you to simultaneously flex your right knee. With your hip extended, flex your right knee. Okay, so right now your right leg should be behind your body and your knee should be bent. Do you feel the muscles in your lower back stretching at this moment, and your leg muscles as well? So with your right knee flexed, I would like you to now plantar flex your right ankle. Okay, if you're going to plantar flex your right ankle, that means your toes are going to be pointed. So at this moment, your right leg should be behind your body, your knee should be bent, and your nose, yeah, your toes, not your nose, your toes should be pointed. Hold on to it for a count of 5. 1, 2, 3, 4, 5. Relax, folks. Go back to anatomical position. Shake it out a little bit. Okay, shake it out a little bit. Go back to anatomical position. Okay. All right. Okay. Let's do this one. Okay. Get into a comfortable anatomical position. Then what I want you to do is bring your arms out straight in front of you, like I am. Bring your arms out straight in front of you like this. Now, what I want you to do next is I want you to flex your elbows to a 90-degree angle. Flex your elbows to a 90-degree angle. Now, with your elbows flexed to 90 degrees, I want you to pronate your palms. So you're going to rotate your thumbs towards your midline, and the palms are going to now be facing away from you. Okay, pronate your palms. Okay, next, I want you to abduct, abduct your fingers, which means you open them up. Okay, so I'm going to open them up and spread them out. That would be abduction. And good, folks. Go ahead, relax back to anatomical position. Back to anatomical position. Okay. Okay, so shake it out if you need to. Let's go back to anatomical position again. Just get comfortable. Give yourself a little space. Be sure you're near a table so you can stabilize yourself. What I want you to do at this moment. Okay, so remember, for example 1, I had you hyperextend your right hip. That's not what I want you to do now. For number 3 here, here's what we do. Starting in anatomical position, I want you to flex. I want you to flex your left knee. So at this point, your left leg should be bent at the left knee. The lower part of your left leg should be behind your body. Now, with your left knee flexed, I now want you to flex your left hip. I want you to flex your left hip. So at this point, as you flex your left hip, your knee stays bent, but your thigh comes up, doesn't it? So your leg should be in front of you. Your leg should be in front of you because you're flexing the hip, and your knee should be bent. So your leg should be hanging down. Your lower leg should be hanging down towards the floor. While you're in this position, and stabilize yourself if you need to, I want you to dorsiflex. Dorsiflex your left ankles. That means your toes point towards the ceiling. Towards the ceiling. Can you feel your gastrocnemius muscle stretching? Now, last thing, folks. So your leg is in front of you, your thighs up, parallel to the floor, your lower leg is down, but your toes are pointed up. What I want you to do next is extend your left knee. Extend your left knee so your leg should be kicking out as though you're doing a front kick in martial arts. Okay, hold it. 1, 2, 3, 4, 5. Go back to anatomical position and relax, relax. Okay. Let's do one more of these. So just shake it out a little bit. If your muscles are feeling tense, just relax a little bit. Okay. All right, I'm going to turn this way to you so that hopefully you can see what I'm doing. Okay, get into anatomical position. Okay, the first thing I want you to do is adduct, ADD, adduct, ADD. I want you to adduct your shoulder blades. So remember, when you adduct a body part, the body part gets closer to the midline. So that means we're doing this motion. Here I go. 1, 2, 3. Right? Your shoulder blades you bring back towards your midline and your chest goes forward. Now, if you're in that position, what I want you to do next, and it's going to be hard for me to say it and do it at the same time, I want you with your shoulder blades back and your chest pushed forward, I want you to protract your head. Push your head forward like a chicken. Okay? Can you feel your neck muscles and shoulder muscles stretching? Now, what I want you to do with your head protracted forward, I want you to additionally protract your mandible. So your head's forward, but now I want you to put your lower jaw forward. Quite a sight, isn't it? Okay, with your lower jaw forward, here's what I want you to do. Depress your mandible, which is to say, open it up. Here we go. Very nice. Folks, go back to anatomical position, rotate, shake it out. If you need to relax, what we can do is circumduct our shoulders. If you need to relax, circumduct your shoulders means you rotate your shoulders posteriorly. So do some shoulder rolls to get those kinks out, okay? There we go. Okay, folks, question in the chat window. Do you feel awake now? Come on, come on. All right. So there you have it, folks. Every day before class, that 8 a.m. class, get up and do some of these motions and stretch those muscles and move those muscles, and you'll feel better. Okay, so go ahead. If you're normally sitting for class, go ahead, sit back down and relax. Okay, gang. That is a lot, but that's the only part of chapter 9 that I'm covering with you. Okay, again, the major anatomy of the major joints at the end of the chapter, you are not responsible for. I am not going to test you on it. Okay, so do you have any questions at this time? Okay, all right, folks. Then that's it for chapter 9. We have about 6 minutes left in our time together. We'll get chapter 10 started next, okay? Chapter 10. Moving right along. Chapter 10 is the muscle tissue, right? You have all been studying hard to learn the identity of the skeletal muscle for your exam coming up this morning. But what we need to do in chapter 10 is describe to you the molecular anatomy of muscle tissue and muscle cells, and get you to understand the process of muscle contraction and the nervous system regulation of that process. There's a lot to do in chapter 10. Okay, so we'll just get started here for 5 minutes. And we'll call it quits. I'm going to end on time today because I want to give you a nice break before you have to take your exam. So chapter 10. Muscle tissue. Okay. Well, I suppose we can give you just a few starting background kind of statements. Okay. The term myology. The term myology is the scientific study of muscles. Okay. The function of muscle tissue the function of muscle tissue is to take chemical energy and convert it into mechanical energy, right? Think about it. I mean, even if you don't know much yet about the intimate details of how muscles do what they do, you appreciate that some kind of biochemical fuel is being burnt so that I can contract my biceps brachii and pull the palms of my hand towards the midline of my body, right? So when muscles do what they do, their job is to take the chemical energy that they've taken in by the food you've eaten over, over the periods of time in your life and transform it into mechanical energy for mechanical motion. Now, when we think about this, right, we just did a whole bunch of those weird little things, moving our legs and arms and things. We think about the mechanical motion of our skeleton, and that's a valid point because that's what skeletal muscle does, right? But we also have like smooth muscle tissue that changes the chemical energy into mechanical energy to close off a urinary bladder sphincter so we don't pee ourselves, right? Things like that are also happening with the more of the invisible muscle that we don't always think about and which we take for granted. Okay, so the function of muscle tissue is to transform the chemical energy into, the mechanical energy, the chemical energy into mechanical energy. Okay. Additionally, okay, Phaedra, I see your comment to me in the chat window. Thank you for reminding me because I do need that. I'm making a note right now. Okay, let's continue here. So additionally to this statement, muscle tissue is going to work to stabilize your body position. Think about it. If your neck and shoulder muscles weren't doing their job very effectively, your head would just kind of lay down, right? It would just bob around, kind of like a newborn infant's head does, right? Newborn infant can't often hold their head up because their muscles are not robust enough yet. They're not strong enough to accomplish that. So additionally, muscle tissue works to stabilize body position, also to regulate organ volume, right? Organ volume. What's the volume of urine in our urinary bladder at this moment? What's the volume of material in our stomach at this moment? What's the volume of material in our large intestine this moment? Okay, so regulate the volume, regulate organ volume. Also, it is the motion of smooth muscle, particularly in our esophagus and more broadly speaking, our GI tract, which propels food and liquid through our body, right? We chew our food up, we swallow, some muscles in the throat contract, we push that material down into our stomach. That material spends some time in the stomach contracts, pushes that material into the small intestine. That material spends some time in the small intestine. The smooth muscle of the small intestine contracts and moves it into the large intestine. Material spends some time in the large intestine. Muscles of the large intestine contract, and then we poop that stuff out of our body, right? So muscle tissue not only stabilizes body position, regulates organ volume, but also propels food and liquid through internal anatomy of the body. Okay, folks, it is 9:15. I'm going to stop because I don't want to go over here. All right, folks, do you have any questions you need to ask before the exam? Okay, I will be online during the exam. If you have a technical problem, if your computer crashes or something odd happens, don't freak out. Send me an email, tell me what's going on, and I will fix it for you. Otherwise, folks, otherwise, good luck. Have a great day, and I'll see you on Thursday, okay? Good luck with your exam. You can do it. See you later.
Thank you.
Thank you.